Question 7 then. As substance A is decaying exponentially, and its mass is recorded at regular intervals, so we've got this function given. Find the time taken for the mass of substance A to decrease to 25% of its value. Well, hang on, it looks a little bit different to what we normally get, but there's not a big deal here. What's its initial value?
40.
40. How do you know that, Harry?
Because when t equals 0, e to the power 0 is 1, so m equals 40.
Okay, so when t is 0, m is 40. So what's the mass when it's decreased to 25% of its value?
10.
10. So actually, this question is really saying find t when m equals 10. So we'll do that. So 10 is 40 e to the minus 0.132t. Divide through by 40. 0.25 is e to the minus 0.132t. There we go. How do we rearrange this to get what t is? Take natural logs of both sides. So natural log of 0.25 is minus 0.132t. So t is minus 1 over 0.132 times the natural log of 0.25. It's just a calculator exercise. Put that into your calculator, and I believe you get about
10.5.
10.5 years to 3 significant figures. There we go. Nice little 3 marks to begin with. Part 2 says find the rate at which the mass of substance A is decreasing when t is 5. What the rate at which it's decreasing? What do we need to find? What's the rate at which something is decreasing? What does that mean?
dm by dt.
dm by dt. It's telling us to differentiate, isn't it? So dm by dt. Remember, again, this you can think of it as the chain rule if you want to. This is, or you can think of that the standard derivative of e to the ax. E to the ax plus b. And you multiply by the a, wouldn't you? So this becomes 40 lots of minus 0.132 e to the minus 0.132 t. Remember this common thing that people get wrong on this, that when we're differentiating e to the ax, the ax bit doesn't change when we've done it. Don't be tempted to try and do anything to that. I did this before. This is minus 5.28. And so all we're doing here is subbing in t equals 5 and getting a value for this as being minus 2.73. And hang on, what did the question say? Find the rate at which the mass of the substance is decreasing. So the rate at which it's decreasing is 2.73 grams per year. Okay. The rate of decrease is 2.73. The rate of increase is minus 2.73. There's a subtle little distinction to make at the end. Now, what was it, part 2? I've labelled these wrong, that was part B. Sorry. That was part B. Part 2 was a little bit interesting. There are a couple of ways that you can do this. I'm just going to do it one of the ways. We're told here there's another substance that is also decaying exponentially. Initially, again, its mass was also 40 grams, but 2 years later, its mass was 31.4. Find the mass of the substance B after a further year. Now you can work out kind of the rate at which it's decreasing and use that in your calculations. I think probably the most straightforward way of doing this is to recognise this is a very similar model that we've got going on to what we just had. So for substance B, we're gonna model it in the same way as what we've just done. We're gonna say it's an exponential decay function. We had an initial value of 40, so it's 40e to the something t. And I'm going to set it up like that. I don't know what k is. I don't know why I'm using k, but whatever letter you like in there. And we have been told that when t equals 2, n is 31.4. So we've got a value that we can sub in. So 31.4 is 40e to the 2k. I would like to know what k is. So this is just another rearrangement of this kind of equation. Divide by the 40. We've just done this, haven't we? We've just solved this kind of equation. So we take natural log of both sides. So k is a half the natural log of 0.785. And that'll do. I could find it on my calculator if I want, but I'll leave it like that for now. The question said, find the value 1 year later. So 1 year later, 1 year on from this, t is now going to be 3. 1 year on from 2 years. N is 40e to the 3 times k, and I've not written it out, but I know what k is. So in my calculator I'm going to do 40e to the half ln 0.785, and I'm going to get 27.8 grams to 3 significant figures. There we go. It was a little bit tricky because it was kind of a funny way of asking the question, wasn't it? But actually, if you fit it to a model that we already knew, then it would have been quite nice.